Richard Tiffin, and Richard is Agrimetrics Chief Scientist Officer and Professor of Applied Economics at the University of Reading in the UK. Please, Richard, the floor is yours.
Thank you very much, Nicola. Thanks very much for giving me the opportunity to talk, and good afternoon, good morning, everybody. It's lovely to be able to talk to you. So I'm going to talk to you a little bit at a very practical level, I think, about how we can help farmers to get value out of the data that we're collecting in both experimental circumstances, but also how farmers themselves can start to contribute in a practical way to assemblies of data that are useful in an experimental sense. So the first thing I want to do is to just talk about how farmers are beginning to derive value from some of the very large data sets that are becoming available to us now. So the first example that I want to talk about is an example which of some work that we in Agrimetrics did with a company called Barfoot's, who produce sweet corn and salad products at a number of farms throughout the world, in Africa, in Spain, and here in the UK. And one of the challenges that they faced, and it's a challenge that's very strongly associated with the creation of food waste, is one of timing the harvest of things like sweet corn, for example. So I'm told, I'm not an expert in this, but I'm told that the demand for sweet corn, particularly in the summer months in the UK, often peaks on a Thursday or a Friday. And the reason why that's the case is because it's commonly used as a vegetable in barbecues. So Barfoot's are contracted by supermarkets, the retailers, the food retailers, to be able to produce their sweet corn and deliver it so that it's in the shops on Thursdays and Fridays in any given week. Now that's clearly a challenge, because sweet corn doesn't necessarily ripen at a regular rate. But what Barfoot's need to be able to do is to time and manage the harvest of the crop and equally the planting of the crop, so that it better meets those contractual obligations that they have with the retailers. And so we developed a predictive model that uses some Earth observation data. It was a model which was created with machine learning, that predicted and forecast when harvests were likely to fall the wrong side of the weekend. And just to illustrate the kind of value that that's able to deliver to farmers, admittedly a very large farming organisation, but the projected saving that an 81% accuracy in predicting the day of harvest will give them is something like £6 million. So the second example I want to give to you is an example really which I think illustrates a very important feature of how we convey information to farmers on the basis of data. And that is that notwithstanding, and we've heard already today of some analyses which are very complex, the way in which the messaging needs to be delivered to the farmer needs to be a simple, easy to understand message that they can act on very quickly. This is a piece of work that we did for BASF, which translated data from a range of different sources, from weather forecasts, from information on where watercourses are, from information on where protected nitrogen zones are, and information on cropping and so on. Connected that to an algorithm that predicted the likelihood of runoff from the application of agrochemicals, and then gave a simple red or green traffic light signal to the farmer to tell them when or not, whether it was safe or not to apply this particular agrochemical to the farm. So this is an app that sits on mobile phones. Anybody can access it. And we did some follow-up work. There are I think there's something like 500,000 downloads of this app. We found that 85% of people found it valuable, and from a water company perspective, this is so critical because you can see here that it costs them £92 million to remove the pesticides from water as they occur. But that's just half of the story, really. So what we're talking about there is taking data that's available in public or semi-public senses and translating that into applications that are valuable and relevant to farmers. The other side of the story, as we've been hearing in some of the other talks, is that farmer data in itself is valuable and can be useful in a practical context, both for farmers, for other farmers, and also for the research community. And the term that's used to describe this, many of you will know this, in medical research in particular, is translational research. And when we talk about translational research, we're talking about research that takes pure scientific research, which medical scientists refer to as the bench research, and translates that to a field. So that could be taking a biotechnology and translating that into a crop, and then taking trials and translating that into practice. And traditionally, and I think we've been talking about that in some of the other talks, traditionally farmers have been heavily engaged in the practice, but have been decreasingly engaged as we move closer and closer to the basic research. Now, what's happening with translational research is that the farmer is starting to get much more engaged much earlier on in the research process, in particular by potentially providing data into that process. So here again, I'm highlighting something that others have talked about. We see what I'm terming a research paradigm shift. So a change in the way in which we do research. And the traditional way of doing it, the good old days, as Nicholas referred to it, was exemplified well by Rothamsted, which is where Fisher did most of his statistical research. And you can see here the classic long-term experiment at Rothamsted, and John Bennett Laws, who was the man who initiated those experiments. And of course, the traditional model was data was very scarce. It was very hard to create meaningful data, and so it was collected and created very carefully in very controlled circumstances, in very controlled experiments. And then people like John Bennett Laws and later on Fisher came and applied their brain power and reached conclusions that were based on increasingly statistical analyses of that data. And of course, what we now find is that we've moved to a situation where data is anything but scarce. We now have huge volumes of data which are available to us in all sorts of different forms. So we have traditional data that will be collected by farmers on what they're doing in terms of applying crop protection chemicals when they're planted. But we also have non-traditional forms of data like social media data and those sorts of things. So a tremendous array of different sorts of data, of different sources of data, and different locations of data. And we now obviously can't analyze that with the human brain. We have to apply machine learning or even more advanced techniques like a deep learning through a neural network as the way of analyzing that. And essentially they do the same thing though. What that machine learning is doing is effectively providing the controls on the experiment so that the data becomes meaningful and we can start to identify individual effects of individual treatments within the data. But the whole approach is very, very different in that we're now relying on data that is collected in the normal run of events. It's not data that's being collected as part of some controlled, carefully planned experiment. So here's an example of how such an approach might lead to value being translated back to the farmer. So the example that I'm taking here is an example where we take a number of farms, so some farms for good business reasons, but also maybe for experimental reasons as well, choose to apply a fairly high level of instrumentation to the farm, to the crop that they're growing. So moisture sensors, pest and disease sensors, solar radiation sensors, etc., etc., etc. So you know, intensively monitored crops. And that could be being used for experimental purposes. It could be providing information into the kinds of experiments that others have been talking about this afternoon. But equally, what we can do with those models is we can take Earth observation data and use that Earth observation data as the basis of a training algorithm that actually reproduces the measurements that are being obtained from the instruments and allows that information to be translated onto other farms. And so this is why I call it transfer learning, because what effectively we're doing here is we're taking precision insights from instrumented farms and transferring those across to farms that are not instrumented. They won't be necessarily of the same quality, but they'll certainly be better than the quality of information that such farms have without these models. And they're enabling, in a sense, the farms, those non-instrumented farms, to adopt the same kind of precision practices that the highly instrumented farms are adopting. So again, value being created for the farmer in that process. Nonetheless, there are some significant challenges in operationalizing this approach. So we've heard the last speaker talking about new ways of collecting data and sharing data across different communities. And what I'm going to talk about here is how you actually take that one step further. And what I would characterize those methods that he was describing as, I would describe those as if you like, organized data gathering and data sharing. And what I think we're starting to see, and we're on the cusp of, is actually what I would call an organic process of data sharing, where we don't organize from some central perspective the sharing of data. Data starts to be shared amongst different practitioners as part of their everyday practices. It's not something that is come from top down. But that, of course, is very difficult if we're going to start to use that approach to create really meaningful big data sets that are relevant to the kinds of analysis that we're interested in. So one can think of a number of different problems. So the data is very dispersed. If we're talking about data that's being collected by farms, then there are many different farms, and it's only relevant if we've got all of the data from all of the farms brought together that we've actually started to create something that is a useful data set. It's probably going to be held in multiple different locations. So even if a farmer uses a piece of software that collects data together and holds it on a central database, there are likely to be many different tools that are being used by farmers, and therefore many different locations where that data will end up. And of course, associated with that, there'll be many different formats in which the data is going to be made available. And then finally, we all know that farmers themselves are very nervous about the prospect of sharing their data. So in Agrimetrics, what we're doing is creating this idea of a data marketplace, which attempts to tackle some of those challenges. And so, first of all, in terms of the data sharing challenge, we emphasize the fact that data sharing will only happen if it's transactional. So a farmer will only share her data if they know that they're going to get something in return back for that action. And what they get back could be an insight. So if you think back to the BASF app, the BASF app, what that farmer is doing, the farmer there is doing, is they're getting an insight back from a central platform. But in effect, and we're not pushing this at the moment, but in effect what they're doing is giving some information in return for that, because they're telling us a little bit about the location of specific crops and the kinds of use that they're making of pesticides. So that kind of transactional data sharing can happen. But equally, it may well be that, that there could be a monetary transaction that takes place. So every time a farmer's data is being used by a scientist or by an agrochemical company in their research activities, there could be a micro payment that is paid back to the farmer as a result of that happening. The second thing that we do in the Agrimetrics data marketplace is put an emphasis on the originator of the data retaining control of that data, and therefore being able to permission that data for how it will be used subsequently. So the farmer who makes their data available to the market doesn't see that data being used by every single participant in the market. It's only the participants that they are prepared to share their data with. So the participants that give them an insight back or give them a monetary payment, and not those, perhaps governments, who may be using data in ways which the farmers are not as comfortable with, or wouldn't wish certain aspects of their data to be seen by the government. And then critically, the final thing that we do in Agrimetrics is to make this data interoperable. So data comes in all sorts of different formats. It needs to be understandable in some detail by the user of that data. And the last thing they want to be doing is picking up the phone and asking the farmer who put the data into the marketplace in the first place for a bit more information about what the data actually represents. So there's a very important piece of providing metadata to make data usable and interoperable, to connect it to different sources to overcome these challenges of different data formats and the like. And we use the W3C standards of the semantic web to make data interoperable. So these standards are open, and others that use these standards will equally well be able to use the data that is provided by Agrimetrics. And then the final challenge that I want to just allude to, where we're doing some work, is this challenge of trust. Now clearly a marketplace only works if the participants in the marketplace trust that it's going to operate according to the rules that it sets for itself, and ensuring that trust is visible and maintained and sustained is a significant challenge. So we've been putting in place some work to understand what we as an organization can do to guarantee to the community of people that we want to be participating in the marketplace that we are to be trusted, that we're not doing things that we profess not to be doing with the data. And the position that we've arrived at actually is that there are a range of different arrangements that can be put in place to ensure that that we are trusted, and which of those arrangements is most appropriate depends on the kinds of users and the kinds of uses that the data is being put to. So at one extreme, a very formalized way of guaranteeing trust is something called a data trust. And you can think of a data trust as being exactly like a financial trust fund. It has a board of trustees who are completely independent of Agrimetrics and who report and are appointed by the communities of stakeholders who are participating in the marketplace. And those trustees are given the right to come and interrogate and, if you like, audit Agrimetrics as much as they possibly like, and to report back to their stakeholders as to whether or not we get a clean bill of health in terms of the trust. Now that's quite a complex, top-heavy, probably quite costly thing to organize, but in some cases, some kinds of data are definitely going to merit that kind of intervention. But then at the other extreme, there are things called data commons and data clubs, which are much more sort of self-organizing communities of people, which are probably more appropriate where data is a little bit less sensitive, but where the members of the club and the members of the community are kind of policing each other as to how data is being used, consumed, and reporting across the community. But in all of these cases, the trust has to come from Agrimetrics saying, or the marketplace saying, we're going to be open to scrutiny from beyond that original beyond the original marketplace. Okay, that's all I wanted to say. Thank you very much for your attention. I hope there was something of interest in there for all of you. And again, thank you for your attention.